getting this set up, I'm going to show you some examples here of redox reactions. So the first one, looking at nitrogen and hydrogen gases combining to form ammonia. Now, just looking at this, is this a redox reaction or not? Remember rule 1, and have these 6 rules sitting out ready to take a look at. Any free element sitting by itself has a charge of 0. So this one's 0 and this one's 0. Now, once they combine, are electrons transferred? Well, nitrogen has a higher electronegativity, and there is a rule with hydrogen, which I'd have to look up and see which rule that is exactly, if it's 2 or 3. But hydrogen is typically a plus. So this one becomes, because there's 3 of them, there's a 3 plus, and the nitrogen takes on those 3, becomes a 3 minus. So from these two, electrons are transferred from the hydrogen to the nitrogen. Now, we're not going to worry about balancing this right now. We're just looking at if electrons were transferred, and how many moles I have in front here doesn't affect that. So I went from 0 to -3. Nitrogen gained electrons. So nitrogen gaining electrons, the nitrogen was therefore reduced. The oxidation number went down. Hydrogen went from 0 to +3. Wait, now. Did I say that backwards previously? This one gained electrons, so it was reduced. Hydrogen, 0. It lost electrons, so losing electrons is oxidation. Hydrogen was oxidized. So this is, electrons are transferred, so this is a redox reaction. I might have said that backwards right at first. I don't remember if I said this was reduced. Yeah, Leo says GER. Losing electrons, becoming more positive, is oxidation. Gaining electrons, becoming more negative, is reduction. Now, this one here, this one's a little bit more complex, but starting off, overall, this is 0, this is 0, and this one just by itself, that one's 0. But looking at the rules, and I believe it's rule 6, is that for group 1, group 2, and aluminum, their oxidation numbers are going to match their group. Well, potassium is in group 1, so this one is going to have a 1 plus, and the chlorine is going to have a 1 minus to balance that out. This is a 1 plus for the potassium. Now the oxygen, the rule for oxygen, which is rule 4 or 5. But oxygen, this is not a peroxide, so each one of these is a -2, so this is a 6 minus oxidation for an O3, because each one is a 2 minus, there's 3 of them, so it's a 6 minus. Overall here, I need this to be balanced, so I need the chlorine to be a 5 plus in this case. So this is a 1 plus because it's group 1 metal. Oxygen is 6 minus. So the chlorine in this case, it loses 5 of its electrons to the oxygen. And so it's a 5 plus. Now over here it's a 1 minus, and the oxygen is a 6 minus to a 0. Now did anything happen to the potassium? 1 plus, 1 plus. It's not a part of what's going on here. The chlorine though, what happens to the chlorine? It went from a 5 plus, it picked up a bunch of electrons to get to a 1 minus. It took on 6 electrons to get to a 6 minus from what it was right here. So this one gained electrons. Gaining electrons is reduction. So the chlorine, Cl, is reduced. The oxygen went from a 6 minus to a 0. So going from a 6 minus to a 0, it lost a bunch of electrons. Losing electrons is oxidation. So oxygen was oxidized in this case. Now, next question is, what is the reducing agent? What allowed chlorine to get reduced? Well, here, oxygen was oxidized, so it is the reducing agent. And chlorine being reduced allows the oxygen to be oxidized, so it's the oxidizing agent. All right, so that's how those work. Writing it out this way, chlorine gets reduced because it gained electrons, becoming less positive, even became negative, and the oxygen became less negative, going to 0, and so it is oxidized, the chlorine is reduced. And then the agents, what gets reduced is the oxidizing agent, and what gets oxidized is the reducing agent. Now this next one, I kind of took up a bunch of room here, but taking a look here at sodium chloride with fluorine gives me sodium fluoride and chlorine gas. So right away I know that this one's 0 and I know that this one's 0, that they're standalone by themselves. Now the NaCl, this one here, the sodium, is a +1 because it's in group 1 metal, so it's a 1+, and so chlorine has to be a 1-. Now over here, chlorine went to a 0. The fluorine here is a 0. Sodium stays as a 1+. The fluorine goes to a 1-. So chlorine, well, let's look at the sodium. Sodium 1+, 1+, it didn't do anything. Chlorine goes from a 1- to a 0. So it became less negative. So the chlorine in this case, it lost electrons. Losing electrons is oxidation. Remember, Leo says Ger. So losing electrons is oxidation. In this case, the chlorine is oxidized, and the fluorine goes from 0 to a 1-, so it gained an electron. Gaining an electron is reduction. Leo says Ger. Write that at the top of the page. Leo says Ger. Write that down. Losing electrons to oxidation, gaining electrons reduction. And then the agents, if it's reduced, it's the oxidizing agent. If it's oxidized, it's the reducing agent. Now, let's take a look at a few more here. Hydrogen gas and oxygen gas becoming water. Is that redox? It's kind of seeming like here everything is becoming redox. The first three is this one. I have a 0 and a 0. Because there is nothing with this, they're standalone, the oxidation is 0 on that one. Now, once they combine, the oxygen takes the 2 electrons from the hydrogen, becoming a 2-, and hydrogen becomes a 2+, following the rules for oxygen and for hydrogen. That hydrogen most of the time will become positive unless it's with a metal. So the hydrogen goes from 0 to 2+. It lost 2 electrons. Losing electrons is oxidation. So the hydrogen was oxidized. Oxygen went from 0 to 2-. It gained electrons because it went more negative. It gained electrons. Gaining electrons is reduction. So the oxygen here gets reduced. Now, this next one here, I'm looking at a lead hydroxide with hydrochloric acid. Gives me water and lead chloride. So, where to start with this? I don't know what this lead is, but I know that this oxygen here is a 2-, and the hydrogen is a 1 plus. If you look this up on table 169, it's going to be a 1 minus. So this OH here, the oxygen is a 2 minus, the hydrogen is a 1 plus, and overall this is a 1 minus, and I have two of them, so this is a 2 minus, so this lead has to be a 2 plus because there is no charge indicated here. So two of these balances out the lead. Now, hydrogen chloride, the hydrogen, following the rule for hydrogen, is a 1 plus, and the chlorine is a 1 minus. Now going over here, the oxygen with water, just like we did up here, is a 2 minus. Each hydrogen is a 1 plus. I have two of them, so that's a 2 plus. Then the lead chlorine, so the chlorine over here being a 2, having two of them, this one here, because it's group 17, it's going to be 1 minus for each one of those, and so it's going to be a 2 minus, and the lead stays as a 2 plus. So lead stayed as a 2 plus, oxygen stayed as a 2 minus, hydrogen stayed as a 1 plus in each case, and the chlorine stayed as a 1 minus for each one. No electrons were transferred here. This is not redox. This here is just a double replacement reaction. The lead took the place of the hydrogen, and we ended up with water and lead chloride. So this is just a double replacement. This is not redox. So not redox. Now let's take a look at another double replacement and see if any electrons are transferred here. Now aluminum, from the rule, from rule 6, that if it's group 1, it's plus 1. If it's group 2, it's plus 2. Or if it's aluminum, it's a 3 plus. So the 3 bromines, each one is a 1 minus, that gives me a 3 minus there. Now the potassium is a group 1, there's 2 of them, so it's going to be a 2 plus. Oxygen, the rule for oxygen, 2 minus on each of those, so that is an 8 minus because there's 4 of them. What does the sulfur have to be? It has to be a 6 plus to balance out this 8 minus with the 2 plus of the potassium. So the sulfur is a 6 plus here. Now, once again, potassium stays as a 1 plus for each one of them. Notice we have a 2 plus here, but we have 2 of them. No electrons are transferred here because each potassium still is a 1 plus. And bromine is a 1 minus, which is just what it is over here. Now the aluminum here, this one still follows the rule. Each one is a 3 plus, and there's 2 of them, so this is a 6 plus. And the oxygen, since there's 4 of them and they're 2 minus each, is 8 minus. The sulfur then has to be a 6 plus because overall all of this has to be a 2 minus to give me a 6 minus to balance out the 6 plus for these SO4s, balance out the 6 plus of the 2 aluminums. So my oxygen stayed 2 minus each, my sulfur stayed 6 plus each, aluminum stayed 3 plus each, bromines were 1, potassiums were 1 plus. So this again is not a redox. Okay, as you go through these, and I'm going to have several of these, and there's going to be some smaller ones in your homework, go through, take a look at these, and remember this. Leo says GER, and have that list of 6 rules with you. So you can justify whether it's oxidizing, it's reducing, it's not an oxidation reduction reaction, and be able to tell which one's the oxidizing agent, or the reducing agent. So for these, just remember, whatever's getting reduced has to be the oxidizing agent. Whatever's being oxidized has to be the reducing agent. All right, good luck with those, and let me know if you have any questions.